This is Honors Pre-Calculus 2013 Final Exam Review. We're doing number 28. It says find the exact value of the expression, find cosine of s plus t given that cosine of s equals 1/3 with s in quadrant 1 and sine of t equals -1/2 with t in quadrant 4. So number 28 is very similar to number 27 in its setup. So I'm going to sort of rush through some of the broad parts of the problem that are similar, that are overlapping, and just really point out the differences, because we have a couple of things here that are a little bit different. Here, instead of being a cosine and a cosine as we did in number 27, we're given a cosine and a sine. And also the angles now are in different quadrants. So angle S is in quadrant 1, angle T is in quadrant 4. So we'll go through this, and I'll go sort of quickly through the parts that overlap with number 27. So if you're confused about that, go back and look at number 27. So for number 28, we're going to start with the formula cosine, and again I'm going to call it a plus b instead of s plus t. I think that'll just be easier for us to work with for the sake of clarity. And we have a formula for that: cosine a cosine b minus sine a sine b, a formula that will be provided to you on a sheet so that you don't have to memorize it. And so our angles that are given information is that cosine of A, remember we're calling S A, equals 1/3, and it tells us that angle S is in quadrant 1, so that's our angle A is in quadrant 1. And then it also tells us that sine of T, so we're going to call that sine of B, is equal to -1/2, and our angle B is in, I shouldn't say equals, it is in quadrant 4. So we're going to use this quadrant 1, quadrant 4 information when we get to the point of taking the square root of both sides of the equation and determining which side is positive and which one's positive, which one's negative. So if I look at how the given information lines up, I have cosine A equals 1/3, so that matches this quantity. I have sine B equals -1/2, that matches this quantity. And that means that what I still have to find out is I need to find out what cosine B is, and I need to find out what sine of A is. So that's where I start, is by finding those things, and I'm going to find this missing information by starting with sine squared plus cosine squared equals 1. So I'm going to start by using cosine A, and we're going to use it to find sine A. And we're going to use sine squared A plus cosine squared A equals 1. Now we're going to plug in our given information that cosine of A is equal to 1/3. So we can plug that in to here. And then we're going to have sine squared A plus, now what we're going to have is our value squared, so that value that we're squaring is 1/3 equals 1. So that's just plugging in 1/3 for the cosine A. Now I say sine squared A plus, square the top, square the bottom, I get 1/9 equals 1. Now I'm going to subtract the 1/9 to the other side, so sine squared A equals 1 minus 1/9. And you can get a common denominator if you like, but hopefully it's fairly clear that 1 minus 1/9 is 8/9. Then I'm trying to get sine of A. I have sine squared of A, so I'm going to take the square root of both sides. So I have sine of A equals, remember whenever we take the square root of both sides of an equation, we're going to pick up a plus minus. So that's plus minus the square root of 8/9. Now we can simplify this square root a little bit, but let's focus first on, am I going to take the positive or the negative? So this is about angle A, sine of A. It's about angle A. So what do we know about angle A? Angle A is in quadrant 1. So if I look at the quadrants, in quadrant 1, the cosine is positive and the sine is positive. So that means when I look at the sine of A, it's going to follow this sine, the sine of the sine SIGN of the sine SINE. So that sign is positive, so we're going to take this positive sign. And then we're going to say sine of A equals positive. And now let's work with the square root a little bit. I can take the square root of the top and the bottom separately. So I'm going to have on the top square root 8. And on the bottom, the square root of 9, I know that that happens to be 3. Now it also would be a good idea for me to simplify this radical square root of 8. Hopefully you know how to do that. I have square root 8. People do this different ways. I'm starting to like the factor tree method. I didn't always. And so we factor this down. If we have a pair, it goes outside. And if I have a singleton, he goes inside. So it's 2 square root 2. So I have 2 square root 2 over 3. And now I have found sine of A, a piece of information that I can plug in to here. So I've found this one. Now I need to also find this one, cosine of B. So I'll do that by working from sine B. So since I know that, that's given information above the line. So since I know that sine of B is equal to -1/2, I'm going to start by saying what is sine squared B plus cosine squared B? Well, I know that equals 1. So for the sine of B, I'm going to plug in this -1/2. So I'm going to put, and that has to be squared because I have sine squared of B. So in here I'm going to put my -1/2, and then that's plus cosine squared B equals 1. -1/2 squared is +1/4, plus cosine squared B equals 1. I'm going to subtract the 1/4 from both sides. And it should hopefully not be too difficult to figure out that 1 minus 1/4 is 3/4. And then I need to take the square root of both sides. Square root and square cancel out, so I have just cosine of B. Now here I have plus or minus the square root of 3/4. Now I need to look back at the quadrant to determine whether I'm going to pick the plus or the minus. So this is about angle B. So if I look up angle B, it says angle B is in quadrant 4. So if I look at the quadrants again, quadrant 4 is down here, and in quadrant 4, the cosine is positive and the sine is negative. So since I'm asked about the cosine, not the sine, I'm going to look at this sine. So for a sine, I looked at the y-coordinate sine. For cosine, I'm going to look at the x-coordinate sine. And that sign is positive, so I'm going to keep the positive again for this one. And then I'm going to start working on simplifying the radical. So now I know that cosine of B is equal to positive, not negative, and I have square root 3 over square root 4, so I can call that square root 3 in the top and 2 in the bottom. This radical is very nice. It's already simplified, so I don't have to do anything to it. There's no radical in the denominator or anything. So now that I know what sine A and cosine B are, I'll notice that I have 4 pieces of information. This formula calls for 4 pieces of information, cosine A, cosine B, sine A, and sine B. But it only gave me 2 pieces of information, cosine of A and sine B. So I used the Pythagorean identities to find 2 more pieces of information, sine of A and cosine B. Now I have 4 pieces of information altogether. So I'm ready to plug into this formula. So we're going to say that cosine of A plus B, I'm going to start by rewriting the formula, equals cosine A, cosine B, minus sine A, sine B. And now we can plug this value in for sine A and this value in for cosine B. And I have my given values up here that I can plug in for cosine A and sine of B. So cosine A, it says, is 1/3. And that is times my cosine B I figured out was square root 3 over 2. And then I have minus. And then my sine of A I figured out to be 2 square root 2 over 3. And my sine of B was given as -1/2. So now it's just a matter of simplifying this expression. And if I look at this, I might first say, can I reduce anything on the diagonals? I cannot. Remember, you cannot reduce 3 and square root 3. We cannot reduce through a square root sign. So all I have is square root 3 on the top and 6 in the bottom. Here I have minus, positive, negative. So when I multiply that all together, I have an even number of negative signs, so I'm going to have plus. I might look for things that can cancel. It looks like we could cancel the 2's here. Cancel the 2 and the 2. Not the 2 inside the square root, but the 2 outside the square root is fine. And now I'm going to multiply my top. Square root 2 times 1 is square root 2. 3 times 1, this is 1 now, is 3. So I have this. This is probably an adequate answer, but I probably should be prepared to simplify that if necessary. So I might think about getting a common denominator for these two. Common denominator is 6, so I'll multiply by 2 in the top and bottom. And now I have, for this one, square root 3 over 6, plus, for this one, 2 square root 2 over 6. And if I simplify that, square root 3 plus 2 square root 2 over 6. And that's our answer. Now, if this were a free response question, then this would probably be an adequate answer. We wouldn't need to find that common denominator. That would be right. But it might be if it's a multiple choice question, the answer available to me doesn't look like this. Maybe it looks like this, so I need to know that I could write this either way. And that's our answer to number 28.